Only also 8.4 theorems about zeros. So y'all, at the beginning of this section, they're going to give us zeros, and they want us to use them zeros to come up with the polynomial that they would have came from. So what we're going to do, we're going to take the zeros and work in reverse until we can get our polynomial. So y'all, let's start this first example. They want us to find a polynomial of degree 3 with real coefficients that has the given zeros. All right, so the zeros are given us are -2, 3, and -6. So they're giving me zeros, and y'all remember, zeros are solutions. So I'm going to write them as a solution, and then we'll work backwards. So the first thing you want to do, you got 3 zeros. So that's how we're going to end up with a degree 3 when we're done. And remember, the degree is the highest exponent we can have, okay? So since these are zeros or solutions, we're going to set x equal to -2, x equals 3, and then x equals -6. So we start by writing them as solutions. Now our next step, we would like to get a 0 on the right side of each of these equations. Because remember, we're going to work in reverse. So to get a 0 on the right side, you're going to add or subtract as needed. So to make this a 0, I'm going to add 2 to both sides. And that'll give me x plus 2 equals 0. Second one, we'll subtract 3 from both sides. And we'll get x minus 3 equals 0. And on the final one, I'll add 6 to both sides. And I get x plus 6 equal to 0. So now that I got 3 equations equal to 0, I'm going to write this as a product of these 3 equations and set it equal to 0, okay? So this is how we're going in reverse. So x plus 2, x minus 3, and then x plus 6. All that we can now set equal to 0. Okay, so remember when we were solving them, once we got them factored, we took each of the factors, set them equal to 0, and then solved for the variable. So we're going totally in reverse. Now here, all these things are being multiplied. So I'm going to multiply 2 at a time. I'm going to start by multiplying the last 2. So I'm going to bring down to x plus 2. And then I'm going to work on the side and figure out what x minus 3. So I got an x minus 3 times x plus 6. So we'll fold that out and then put that in here behind that x plus 2. So x times x gives us an x squared. X times 6 gives us a 6x. -3 times x is a -3x. And then that -3 times 6 is a -18. So then all I got to do is add my like terms in the middle so that I get an x squared. 6 minus 3 give me a positive 3x minus the 18. So I'm now going to put that over here. X squared plus 3x minus 18. All right, so we foiled the first two. Now we got this parentheses times this parentheses. So we're going to multiply all of this. Since it's the last thing, I'll just multiply it in over here instead of going to the side. All right, so we distribute the x times all three of these, and then we'll come distribute that 2 times all three of these. So both of these have to multiply by all three of these. So y'all, here we go. X times x squared is the x to the third. X times 3x is a 3x squared. X times negative 18 is a negative 18x. So all we did when we distributed that x, we added 1x to everybody, okay? Now let's distribute our 2. So 2 times x squared is a 2x squared. 2 times 3x is a 6x. And then finally, 2 times negative 18 is a negative 36. And y'all notice, all we can do now, add like terms. So the x3 comes down. Let's see, the x squareds, I got 3x squareds plus 2x squareds. That'll give us 5x squareds. On the x's, I got a negative 18x, positive 6x. That'll give us a negative 12x. And then what's left? Our negative 36, bring that down. All equal to our 0. So this is our polynomial. So they'll have, the answer blank will have something like f of x equals, and then we just write in our polynomial. We got our x to the third plus 5x squared minus 12x minus 36. Okay, so that right there is what Math Lab's wanting. So remember, they said a degree 3, and y'all look at that. Our highest exponent is a 3. So y'all, that's the trick on these is starting with your zeros and working in reverse, okay? So if you'll notice, these are going to have a little bit of multiplication in them. Hey, also, this one wants the same thing. Write a polynomial. Whose zeros include 4, 7i, and negative 7i. So we got some imaginary zeros this time, okay? But y'all, we're going to work it the same way. We got 3 zeros. So we're going to set them up as solutions. So we got x equals 4, x equals 7i, and x equals a negative 7i. Okay. Now notice, like up here, we need to get a 0 on the right side. So we're going to subtract 4 on the first one. So I get x minus 4 equals 0. Right here, we'll subtract 7i from both sides. And on the third one, I'll add 7i to both sides. So this one will give me x plus 7i equals 0. All right, so we got zeros on the right side like we did up here. So now we're going to write each of these factors as a product equal to 0. So I'm going to put them in parentheses. X minus 4 times x minus 7i times x plus 7i, all that equal to 0. Now, y'all, I'm going to be picky on this one. Anytime I got imaginary factors like this, those are the two I'm going to start with when I multiply. So I'm going to go to the side right here. And we're going to FOIL out our x minus 7i times x plus 7i. Now, y'all, there's one thing about when you multiply these are conjugate pairs. Conjugate pairs look the same, but they got different operations. But everything's the same other than that subtraction and that addition. Now, another thing you need to know about when you got imaginary things you're foiling, anytime we get an I squared, if I get an I squared, I got to turn that into a -1. So I times I in the long run equals -1. So here's the little property about foiling conjugate pairs of imaginary numbers. When you foil conjugate pairs of imaginary numbers, the imaginary stuff will go away. It's going to all cancel out and be gone. So, y'all, I'm going to show you how that's going to happen. So this x times x is x squared. X times 7i is a 7ix. Now we distribute that -7i. -7i times x is a -7ix. And y'all, a -7i times a +7i is a -49i squared. Now you also notice in the middle, the +7i and a -7i, those right there are going to cancel. So I'm going to bring down my x squared minus my 49. I got an I squared, and guess what? We said I squared equals -1. So I'm going to replace the I squared with a -1. And y'all, guess what? That -1 is now going to turn my -49 into a +49, so that I get x squared plus 49. So look, the only purpose this I square serves is to change the sign of the number in front of it, okay? Now notice, the i's are gone. There's no more i's in this, so I'm going to bring down that x minus 4, put in my x squared plus 49, and all that's still equal to 0. So now we got two things times two things. We're going to multiply this. Y'all, since I'm down to the last thing I'm multiplying, I'm just going to work them over here, okay? So I got an x times an x squared. That'll give me an x to the third. I got that x times 49. That'll give me a 49x. I got a -4 times the x squared. That's a -4x squared. And then I got a -4 times 49. That's going to give me a -196. Now, when I put this in, there's one thing I'm going to do to this. when I put this in my answer blank. So let me see what my chat's saying. Yeah, so we're going to rewrite it and we're going to actually put this in descending order. There you go. So put our x3 first, then our negative 4x squared, then our 49x, and then our negative 196. And y'all, that's there is what Math Lab's going to want. Okay, so remember, conjugate pairs of imaginary numbers will always get rid of the i's when you FOIL those, okay? And always remember that the I squared equals -1 on those. So now, let's play with some radicals. So let's get the camera back up. All right, y'all, so the same thing. Find a polynomial of lowest degree whose zeros are square root of 7, a negative square root of 7, and 3. All right, y'all, so I'll tell you a trick. I got 3 zeros, so when I'm done, my highest exponent has to be a 3 on this, okay? So the number of zeros will tell you what the highest exponent is when you're done. All right, so write out 3 answers. We got x equals a square root of 7, x equals a negative square root of 7, and x equals a positive 3. So y'all, the same thing. We need zeros on the right side, so add and subtract as needed to get them numbers moved over. So the first one, we're going to subtract square root of 7. And I get x minus square root of 7 equals 0. Second one, I'll add square root of 7. And I get x plus square root of 7 equals 0. And on the third one, we will subtract 3 and get x minus 3 equal to 0. So I now have 3 equations equal to 0. I'm going to write that as a product equal to 0. So I'm going to put in my x minus square root of 7, x plus square root of 7, and then x minus 3, all equal to 0. So y'all won't go. I was picky when I had the imaginary stuff. I wanted to multiply the imaginary stuff first. Well, when you got radicals, and guess what? These are conjugate pairs. Everything matches up except for the subtraction and addition. So I have conjugate pairs again. So we're going to start out by multiplying the radical stuff. So over here on the side, we're going to multiply x minus square root of 7 times x plus square root of 7. Now, what will help us in this section right here is to remember a square root of a times a square root of a equals a in the long run. Okay? So we're going to have to know that because we're going to have a square root of 7 times square root of 7. So let me show you what's going to happen. So we'll start out doing x times x and get an x squared. X times square root of 7 is just a square root of 7x. Negative square root of 7 times x is a negative square root of 7x. And then watch this. A negative square root of 7 times a positive square root of 7 is a negative square root of 49. So y'all notice, right here I kept the x's on the outside because numbers underneath the radical cannot multiply by numbers outside a radical. So you got to write them with that x on the outside. But right here, when I got to 49, numbers under radicals can multiply by other numbers under a radical. So that 7 times 7 gave me that 49. But y'all look at here. Positive square root of 7x and a negative square root of 7x, they cancel. So I'm going to bring down my x squared. And then that's going to be minus. And guess what? The square root of 49 is 7. So notice in the long run, that square root of 7 times that square root of 7 basically gave me a 7. And y'all notice what else? Conjugate pairs of radicals get rid of the radicals. There's no radicals left in this answer. So let's bring that over here. X squared minus 7. What's left is my x minus 3. And all that equal to my 0. All right, so all we got to do is multiply this out, and we're done. All right, y'all. X squared times x gives me my x to the third. So we knew we needed an exponent of 3 because we got 3 zeros again, okay? All right, x squared times negative 3 is a negative 3x squared. Then I'm going to distribute the negative 7 times x is a negative 7x. And then finally, negative 7 times negative 3 is a positive 21. So y'all, this polynomial, and look here, we're in descending order already, and there's no like terms. So I'm just going to put in my x to the third minus 3x squared minus 7x plus 21. Okay, y'all, so not bad. We're just hitting you with a little bit of imaginary conjugate pairs and radical conjugate pairs. All right, so y'all, I've thrown real numbers at you. I've thrown imaginary numbers at you. I threw radical numbers at you. So I guess what's left is your fractions. So we're going to find a polynomial degree 3. With zeros of negative 1/5, 0, and 2. Okay, so I got 3 zeros. That's why we're going to end up with a degree 3. So we got 3 zeros. Let's write out our 3 solutions. X equals a negative 1/5. X equals 0. And then x equals 2. So look here. When you got a 0 as one of your zeros, there's nothing you can do that. X equals 2 already has a 0 on the right side. So we need to work on the fraction and the 2. So for this one, I'm going to add 1/5 to both sides. So I get x plus 1/5 equals 0. All right, we already had a 0 on that one, so we need to work on the third one. So y'all here, we'll subtract 2 from both sides. And I get x minus 2 equals 0. Now, y'all, I'm a little picky on these ones. Anytime I got single x's like that, I put them in the front, and then I'll start putting all my parentheses. So I got a single x as a factor, so I'm going to bring that down. Then I'll put my x plus 1/5 in parentheses. And then I'll put in my x minus 2. Okay. Now, you don't have to do this same order. I just think it's easier to take care of this foiling and then just distribute that x when we're done, okay? So here I'm going to start out by multiplying that. So I'm going to work that on the side again. My x plus 1/5 times x minus 2. And then remember, y'all got calculators. If you don't like multiplying and adding fractions, your calculator will do all that fraction stuff for you, okay? So let's FOIL. X times x is x squared. X times -2 is a -2x. 1/5 times x is a positive 1/5 x. And y'all finally, 1/5 times -2. So you would treat the 2, remember, like it's got a 1 when you're multiplying, and you multiply straight across. So top times top will give me a -2. And in the bottom, 5 times 1 is 5. Now, here's the tricky part. You got like terms here. So on your calculator, if you want to, you can do a -2 plus the 1/5 and see what you get. So let's see. We're going to bring down the x squared. -2 plus 1/5 is going to give you a -9/5 x. And then minus your 2/5 at the end. So y'all, let me show you on the calculator real quick. So I had what, -2? So I'm going to do -2 plus, I had 1/5. So I'm going to make it look like a fraction by hitting the green alpha button and y equals and hit enter for ND. Then I'm going to put in my, what I have, 1/5. So 1 on top. On bottom, I'll put in my 5. So -2 plus 1/5. Since I wrote it as a fraction, it'll actually give me my answer as a -9/5 in fraction form. Okay. All righty, y'all. So bring down that first x. And then this gave us x squared minus 9/5 x minus 2/5. Now, the reason I saved this x for last is because now I just got to multiply everybody by x. So x times x squared is an x to the third. And we knew we needed an x to the third because they said I needed degree 3. X times -9/5 x is -9/5 x squared. And then my x times -2/5 is a -2/5 x. So all that equal to 0. So in MATLAB, remember, they're going to have f of x equals, and let's see, we're in descending order already. So we got our x to the third minus 9/5 x squared minus 2/5 x. Okay, y'all, so remember, don't be worried about your fractions. Push them in that calculator and knock them out quick, okay? Because we got them TI-84s. Hey, y'all, so I got one more of those, and then we sort of switch the game up a little bit. So let me get my paper fixed. So y'all, the same thing, but they're going to use different terminology here, okay? So here they want me to find a polynomial degree 4. With -4 is 0 of multiplicity 3. And 0 is a 0 of multiplicity 1. All right, so I got to end up with a degree 4 when I'm done. So x to the 4th has to be my highest exponent. So if I'm going to end up with a degree 4, that means I need 4 zeros. And y'all, that's where this multiplicity comes in. Remember, this multiplicity 3 is telling me that this -4 is a 0 that's going to happen 3 times. So we're going to come in and write x equals -4 3 times. Then they say, hey, 0 is a 0 of multiplicity 1. So that means x equals 0 is only happening 1 time. So y'all remember, the multiplicity always tells us how many times a 0 occurs, okay? So now, I don't have to do nothing to that one, but on these 3, I got to add 4 to both sides. So we're going to come in and add our 4s. So I get x plus 4 is 0, and y'all, we're going to get that 3 times here. All right, then my last one here. And then, like I said, x equals 0, nothing we got to do to that one. So now, remember, I'm going to write them as a product here. So my single x, once again, I'm bringing that down to the front. So I'm going to have my x and then 3x plus 4s. All equal to our 0. Okay, so I got 4 things being multiplied. So I'm just going to multiply 2 here. I'll multiply the first 2. And I'm also going to multiply the second 2. So I'm going to multiply these 2 and these last 2. So I'm going to come to my side again. And we'll do x times x plus 4. And see what that equals. And then we'll do x plus 4 times x plus 4. and see what this equals. Now remember, those are not conjugate pairs because one's not being subtracted. So you won't get stuff canceled as much when you got things that are not conjugate pairs, okay? All right, y'all, so right here, we're going to distribute an x. X times x is x squared. X times 4 is a positive 4x. So that can be nothing else done to it. So my first parentheses will have x squared plus 4x. Now we got to see what we're going to get right here. So let's do our x times x and get an x squared. X times 4 is a 4x. 4 times x is a 4x. And then finally, 4 times 4 is 16. But y'all remember, those don't cancel. They're both positive. So bring down this x squared. 4x's plus 4x's gives us 8x. And then plus our 16. So that's going to go in these second parentheses. X squared plus 8x plus 16. All righty, so this is why support was having you multiply two things times 3, because that's what we're doing right here again. So we now will multiply all of this. Remember, I got to end up with a degree 4. So here we go. X squared times x squared is going to give us a x to the 4th. X squared times 8x is an 8x to the 3rd. X squared times 16 is a 16x squared. So notice, all I did when you multiply through x squared, you're just adding 2 x's to everybody. All right, y'all, let me find where I'm at. Okay, right here, I'm going to distribute that 4x. 4x times x squared is a 4x cubed. 4x times 8x is a 32x squared. And then 4x times 16 is a 64x. All righty, y'all. Remember, all that's sort of technically equal to 0 still. All right, so let's come and add like terms. So I got my x to the 4th in the front. Let's see. 8x cubed, 4x cubed. Give me 12x cubed. Y'all, what's next? 16x squared plus 32x squared. Ooh, that's giving me what? 48x.
48x squared.
Uh-huh. All right, let's see. Where's my... Oh, I just got the 1x down here, so bring down our 64x. All righty, so my f of x will equal x to the 4th plus 12x cubed plus 48x squared plus 64x. All righty, so Now we're going to look at a few rules we got about these zeros. All right, so what we're talking about is certain rules that always apply. So when we're looking at imaginary zeros, so like my 7 eyes and my 3 eyes and all that fun stuff, well, imaginary zeros always come in conjugate pairs. So y'all, what I mean by conjugate pairs, if say negative 3i, if negative 3i is a zero, then a positive 3i must also be a zero. So that's what we mean by they coming in conjugate pairs. Okay. Now, if they're written like complex numbers, if something like 2 plus 7i is a zero, then the conjugate of this would be 2 minus 7i. It must also be a zero. Okay. So remember, now notice the twos don't change sign. It's just this imaginary stuff that's changing the signs, okay? So imaginary zeros will always come in conjugate pairs. And then how about those radical zeros? Like my square root of fives and all that fun stuff. Well, y'all, guess what? They always come in conjugate pairs. Okay, so that means if square root of 3 is a zero, then a negative square root of 3 is also a zero. So that's like on that second one and third one that I foiled out. That's why when they gave me, I think what was it, the square root of 7, they gave me the negative square root of 7. And then on the i's, they gave me one positive and one negative, okay? All right, also, these could be written as a real number and a radical. So if I had something like 5 plus square root of, oh, what I want here, how about 6? If 5 plus square root of 6 is a zero, then 5 minus square root of 6 is also a zero. Okay, y'all, so remember this. Imaginary conjugate pairs, radical conjugate pairs. That's about to help us on these next few questions I'm going to do, okay? So y'all, suppose a polynomial degree 4 has let me find it, -3, square root of 3 and 6/5 at some of its zeros. Find the under zero. Alrighty, y'all. So you have a degree 4, which means it has 4 zeros altogether. They're giving me a -3. They're giving me a square root of 3, and they're giving me a 6/5 as some of the zeros. So y'all, what is that fourth zero?
-6/5.
Well, remember, we didn't have a rule about fractions, but you're on the right track. But which one of these three did we have a rule about?
The radical.
The radical. So if a square root of 3 is a 0, then the
So negative square root of 3.
Negative square root of 3. There you go. All righty. Suppose a degree 4 polynomial has zeros of a I and a 6 minus square root of 11. Well, what are the under zeros? And let's think about this one. I've got a degree 4, which means I need 4 zeros. They're giving me 2. They're giving me an I and then a 6 minus square root of 11. So any guesses what these other 2 zeros might be?
Positive square root of 11.
Okay, now write that whole thing together, make that a 6.
6 plus square root of 11.
6 plus square root of 11 is one of them. So that takes care of that number.
And negative I.
And a negative I. There you go. All righty, so let's see. Let's knock this one on out. Suppose a degree 4 polynomial has zeros of 2 plus 2i and 1 plus the square root of 5. What are the other zeros?
Two minus 2i and 1 minus square root of 5.
Perfect. There you go. Now I'll tell you why they're letting you know this kind of information for what's coming up here, y'all. Back to the foiling.
I was just going to get ready to say, you must be getting ready to throw us a curveball.
Now, check this out. We're going to find a polynomial of lowest degree with negative 4i and 2 at some of its zeros. So they're not giving away how many zeros I'm ending up with because they're just telling me it's got to be lowest degree. So they're giving me 2 zeros. So if they're giving me these 2 zeros, Is there anything missing?
A positive 4i.
A positive 4i. So we know a positive 4i also must be a 0. So we're going to have x equals 4i, x equals a negative 4i, and x equals 2. Okay, so we said over here, since negative 4i is a 0, then 4i is also a 0. Okay. All righty, so here we go. Get zeros on the right side. So we'll subtract 4i on the first one. Add 4i on the second one. And then subtract 2 on our last one. All right, y'all. So we got all of our equations. Now we're going to write it as a product again. X minus 4i, x plus 4i, and then x minus 2. All written as a product equal to 0. And y'all remember this, we're going to start with our conjugate pairs of imaginary numbers. So I'm going to multiply that first, and I guess we'll do that on the side here. X minus 4i times x plus 4i. Now that we've fooled enough conjugate pairs now, that I'm going to show y'all we can shortcut this stuff. We don't have to multiply all 4 terms every time, because y'all, this outside 4ix and this negative 4ix on the inside, they're going to cancel 100% of the times. So on this one, I'm going to show you how to shortcut FOIL, since this stuff is conjugate pairs. So to shortcut this, all we got to do is multiply the first 2 together. The x times the x will give you an x squared. And then you multiply the last 2 together. So the negative 4i give you a negative 16i squared. Okay, now you can only shortcut FOIL when you got the conjugate pairs, okay? Now, what do we say I squared equals?
-1.
All right, so I'm going to turn that into a -1. And once again, all that -1 is going to do is make my negative 16 a positive 16. So that I get an x squared plus 16. So y'all, we can write that in front now. And then bring down that x minus 2. All right, y'all. Now I'm just going to FOIL stuff out. X squared times x is an x to the third. X squared times -2 is a negative 2x squared. 16 times x is a 16x. And then finally, 16 times -2 is a negative 32. Alrighty, then once again, our polynomial, x to the third minus 2x squared plus 16x minus our 32. So yeah, when they want you to find a polynomial and they give you an imaginary number, you automatically got to assume that its conjugate is also a 0. All right, y'all. So let's see what y'all do to my next one then. Whoops, that's both sides of that. So once again, whoops, let me pull that up. Find the polynomial of lowest degree. With the following as sum of its zeros. So notice they're not telling me the degree again, okay? So now the ones that are sum of its zeros is a square root of 5 and a 5i. So what does that mean? If a square root of 5 and a 5i are sum of its zeros, are there anything?
Negative.
Uh-huh.
Negative square root of 5 and negative 5i are also zeros.
Uh-huh. So then we know negative square root of 5, negative 5i are also zeros. Good job. So I'm just going to put my radical ones together and then my imaginary. So let's see. I'll do x equals square root of 5. X equals a negative square root of 5. X equals 5i. And x equals a negative 5i. So yeah, y'all, you had to assume the conjugates of both of these on this one, okay? So here we go, add and subtract, get everything to have a 0 on the right side. So subtract that square root of 5 from both sides on the first one. Add square root of 5 on our second equation. Subtract 5i on the third. Oh, and then finally add 5i to the fourth one. So since we got 4 zeros, we're going to end up with an x to the fourth as our highest exponent, okay? So that degree always matches our zeros. So y'all, let's put them in as a product. And then I got what? X minus 5i, x plus 5i. I got 4 things being multiplied. So once again, I'm going to multiply these first 2 and my last 2. And I guess I'll just keep them in line here. So for my first parentheses, guess what? Whoops, where'd I lose a sign? That's a plus right here, y'all.
So they're conjugate pairs, then we can just assume that you'll get x squared minus 5.
X squared minus 5. Perfect. Okay, because remember, square root of 5 times square root of 5 is just a 5. So what about the second one? It's going to be what, an x squared?
It's going to be an x squared plus 25 because negative 5i times the 5 positive 5i will make the negative 25i squared. But the I squared is a negative 1, making the negative 25 a positive 25.
Perfect. And guess what? Imaginary always ends up as being added. The radical stuff always ends up being subtracted, okay? So remember, when you multiply these conjugate pairs, And y'all, the calculator will do a negative 5i times 5i and actually give you that 25 on it, okay? So just remember, negative 5i times 5i was a negative 25i squared, which turned into that positive 25. All right, y'all, guess what? We just got to multiply this and we're done. So the x squared times the x squared, that's going to give me my x to the fourth. So I had 4 zeros. I needed that exponent right there. X squared times 25 is a 25x squared. Oh, what's next? Negative 5 times x squared is a negative 5x squared. And y'all, finally, the negative 5 times 25 is a negative 125. All right, y'all, can we go any further?
You can combine like terms and make it an x to the fourth power plus 20x squared minus 125.
There you go. And at that point, I know that's going to be my f of x, okay? All righty. So, let's see. So now we're going to go back and we're going to find zeros from a polynomial. So the thing we do on these, let me write this one out for you. So example, the polynomial has the given zero. Then they say find the other zeros. So my polynomial is f of x equals x to the third plus 3x squared minus 7x minus 21. And the zero they're giving me is a negative 3. So y'all, here's the thing. We're going to divide this zero out by using our synthetic division. And then we're going to look at the quotient that's left. Remember, if I start out with an x to the third, the quotient I get will be an x squared because it goes down by 1 degree every time. And since I'm at an x squared with those quotients, I will get the last 2 zeros by either doing the quadratic formula or square root or something like that. But I got to get it down to an x squared before I can do those quadratic methods. So if you start with an x3, you got to do synthetic division 1 time to get it down to an x squared. When I do one with an x4, I've got to do synthetic division twice because it'll start out as an x4. I'll turn it into an x3. Then I'll turn it into an x squared. I got to get it down to the x squared terms or the quadratic type equations before I can get my last 2 zeros. So since they're giving me negative 3 as my first zero, that's going to be my C to start out with. And then I'm going to write down my coefficients. 1, 3, negative 7, and negative 21. Notice nothing was missing. I had my x3, I have my x squared, I had my x term, and I had my constant term, my number. So now I'm going to draw my box. So what's going to happen, I'm starting out with 4 numbers when I got an x to the third. That's going to leave me 3 numbers right here that are going to represent my x squared equation, okay? So the numbers under the bar are the coefficients of your new equation. So here's a question for y'all. If I know this -3 is a 0 of this polynomial, if -3 is a 0 of that, what will this remainder be?
I got 0.
Perfect. And it's got to be a 0 here. Remember, that's how we were checking to see if those numbers were actually zeros, if we got a 0 remainder. So since they're telling me that, we better get a 0 there. Good job. So let's see. You brought the 1 down. 1 times -3 was -3. You added that and got me a 0. 0 times -3 was 0. Adding those, we get a -7. And y'all look at that. -7 times -3 is 21, which gives me a 0 remainder. Well, we knew that because they gave me that 0. So we got to find those other 2 zeros because there's 3 altogether. So these are the coefficients of the new polynomial that you get after you divide that out. Now, this was an x3, so this is going to start as 1x squared. So 1x squared.
But if the next coefficient is a 0 for any form, then we're missing something then, right? Because we replace what was it when we're missing a variable or the next term, we replace it with 0 whenever we were solving these on Tuesday.
Yeah.
So does that mean we're
Well,
missing
you'll
something?
see one of those. This one wasn't missing anything here. It had everything here, right? Now, this
Right.
is telling me, this is just a placeholder telling me I got 0 x's, but I don't have to write that down here. All I got to do is bring down my -7 and then set all this equal to 0.
Okay.
Because now it's quadratic. And since it's quadratic, I can solve it. Well, this one, when I got an x squared in a number, I'm just going to take square roots of this one by adding 7 and then doing square roots. So we're going to solve this now. So I'm going to add 7 because that's the quickest way. You don't want to do that big old quad formula for something like this. So
So
bring
I
that
have positive square root of 7 and negative square root of 7.
Bam, there you go. Because when I do square roots, we always got to count for both sides. So good job. And then we couldn't do nothing to that. So that's just going to stay a positive or negative square root of 7. Now, here's how the answer is going to be. The answer will say the other zeros. Well, we don't put the -3 or it'll mark you wrong. We just need to put in you can either use the plus or minus square root of 7, or you could do a square root of 7 and then a negative square root of 7, either way. But they will let y'all use the plus or minus if you want, okay? So yeah, that's it. Once we can get it down to 3 numbers or less, we use the quadratic stuff.
And then just skip over that 0 and act like it's not there and just go to the next placeholder.
Yeah, because you could have put a 0x here, but remember, 0 times x is a big 0 anyway, so it gets rid of it anyway.
And it would have just confused me even more and made me think I was missing something.
Yeah. All right, so let's see what we do here. This one's going to be fun. So for the polynomial, 1 0 is given. They say find the remaining zeros. Now my polynomial is P of X equals X to the fourth plus 40X squared minus 441. And y'all, the zero they're giving me is 7i. Now, that's going to be my first C. Now, notice this is the x4. So we're going to have to do synthetic division twice. The first time we'll get an x to the third equation. We'll use those numbers on synthetic division and get it down to 3 numbers like we did here. Okay?
So we can already assume that negative 7i is one of our other zeros, right?
Oh, dang, you done. Okay, so you done gave away the fun. But that is true. So I'm going to do 7i the first time, and then, like you said, the second time I'm going to do the negative 7i.
Negative 7i.
There you go. Now, here's where you got to watch out from. There's not an x3 term here, so we're going to put a 0 for the x3. There's not an x here either, so we're going to put a 0 for the x. So when you write your numbers, you'll have that 1, a 0 for the x3, a 40 for the x squared, a 0 for the x, and then a negative 441. So if you'll add 1 to the degree, that tells you how many numbers you need. So 4 plus 1 is 5, so I needed 5 numbers here. So you have to have them missing placeholders to be the zeros, okay? And y'all, once again, I know my remainder better be 0 on this. It's a little tricky with these i's. So here we go. We're going to bring down to 1. 1 times 7i is 7i. 0 plus 7i is 7i. So let's see what y'all would get here. In your calculator, will multiply these. But y'all, what is a 7i times a 7i?
Negative 49.
Negative 49. Because remember, you get a 49i squared, but the I squared is going to make it negative. All right, that's going to give me what, a negative 9 there. So negative 9 times 7i is a negative 63i. Well, adding that to 0, that's a negative 63i. So we just got to figure one more out. What is negative 63i times a 7i?
Negative 441, making it a positive 440. Well, negative 441i squared, making it a positive 441.
There you go. Okay. And the calculator will spit out that 441 really quick. And y'all, I don't remember if I told you, but the I on the calculator is the second decimal on there, okay? All right, which gives me a remainder of 0. So now remember, this is like an x to the third plus 7i x squared minus 9x minus 63i. So those are the coefficients that we're going to use again when we do our synthetic division. So bring down your 1, 7i, negative 9, and negative 63i. Make your bar. And I guess what is my next 0 that I'm trying?
Negative 7i.
Negative 7i. And that's why they only gave you 1 on these, because they still wanted y'all to remember that conjugate stuff, okay? All right, y'all, so when we spin this, we better get a 0 again. So here we go. We're going to bring down our 1. 1 times negative 7i is a negative 7i. Well, look at that. A 7i, negative 7i they're going to zero out. 0 times negative 7i is 0. Negative 9 plus 0 is negative 9. And y'all, there's a negative 9 times a negative 7i.
Making it a positive 63i.
Making that a 63i. Good job. Well, it gets tricky because some people say I squared, but remember, there's not an I after that 9 this time, okay? So those two add up to give me a 0. So for the other zeros, so far, I know a negative 7i is one of my other zeros. Okay, remember, don't write the 7i because they gave us that one. But guess what? We got 3 numbers. So this is like x squared. 0x, I don't have to write, minus my 9. And I'm going to set that equal to 0. So if you notice, most of these in this homework, you're getting zeros in the middle. So basically, let's do that square root stuff again. So we're going to add 9. So x squared will equal 9. Square root that, y'all. So we're doing a number, so that's going to be a plus or minus. So x will give me what? A plus or minus. Square root of 9 is 3. So there's 2 zeros plus 1 that we found already is 3, plus the 1 they gave us is 4. And that matches what we need for that x to the 4th. So come in and put the other zeros are negative 7i, 3, and negative 3, okay? All righty, y'all. So one more problem dealing with these zeros. And this one we're actually going to be able to graph, so that's what's nice. But this one wants me to do other things. So it says find the rational zeros. And then the other zeros. And then it says factor into linear factors. So y'all, let me tell you what they're talking about with this rational zeros on that problem we just did. On this problem right here where I got 7i and or zeros were 7i, negative 7i, 3, and negative 3. On this one, the rational zeros would be the 3 and the negative 3. Rational zeros are numbers that can be integers or fractions. So my rational zeros would have been the 3 and the negative 3. The other zeros would have been the negative 7i and the 7i. Because they're not rational numbers, they're imaginary numbers. Okay? So radical zeros and imaginary zeros are what you would consider as those other zeros, okay? Now, on the one we gave y'all in the problems, you're only going to have 3 rational zeros. There won't be any of these other ones, okay? So y'all shouldn't get I's on this one or radicals. So we're going to have f of x equals x to the 3rd minus 21x plus 20. Now, y'all, they didn't give me any zeros on this one. So you could do what we call trial and error. Trial and error method is where you take all the factors of this 20 and you run them through synthetic division until you get one that gives you a zero remainder. Because once you get a zero remainder, you know then that that number is a zero, and then you can use those numbers to get the last two doing the quadratic stuff. Because since that's an x to the third, you could start running through factors of 20. Now, another way you can shortcut it is to graph this in y equals and look for where this thing is crossing the x-axis. So y'all, I'm going to sort of show you how you can do it both ways. So the trial and error method, first, and then I'll show you how to graph it. So I need factors of 20. And I always start with my 1 and 20, 2 and 10, and what's left, y'all? 4
and 5.
and 5. Now remember, these could be two positives or they could be two negatives. So you always want to check the positive and negative of each number. So I would start with the smallest numbers and move my way toward the bigger ones. So the first number I would check with my synthetic division would be a 1. Okay. Now we got to write out our coefficients. And y'all guess what? We don't have an x squared here, so we're going to put a 0. So we got a 1, 0, negative 21, and a 20. And we're praying for a 0 here. Okay? Because if I don't get a 0 here, I'm going to try negative 1 next. If I don't get a 0 for negative 1, I'm going to try the 2 next. And I'm going to keep on going until I get a 0 remainder here. Okay? So this is called trial and error. And you always look at the factors of this last number. All right, y'all. So here we go. Praying for a 0. So bring down to 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Oh, I'm starting to get happy because negative 21 and 1 gives me a negative 20. And negative 20 times 1 is negative 20. Y'all, that means I get a 0 remainder. So remember, 1 degree less than an x3. So we're happy. We know 1 is definitely one of our 3 zeros, okay? Because we got to get 3 because of that exponent. So remember, this is now an x squared plus an x minus 20 equal to 0. So y'all, I can't do the square roots because I got an x term. So the two choices are we can try to factor this or use the quadratic formula. So I'm going to try to factor it first. But that's usually easier than the quadratic formula. So we got an x squared here, so that'll be an x and an x. Since the last number's negative, we're going to have one factor positive, one factor negative. Now, I need factors of 20 that'll subtract and give me a 1. Well, we got our factors right here of 20. And the ones that'll subtract and give me a 1 are going to be 5 and 4. Now,
The 5 will go with the positive because it's the larger number, and then the 4 will go negative.
Perfect. Always the larger number has the same sign as the middle. Good job. All right, y'all, I got my last two. So it did factor. So now we can set x plus 5 equal to 0. X minus 4 equal to 0 and get those last two zeros. So y'all, let's subtract 5. And then here, I'll add 4. So our zeros we now have are, what was my first one? A 1, a -5, and a 4. We lucked out on that +1 being a 0 for this. But if it wasn't, remember, I'd have went to the -1, and then I tried 2, -2, all the way through my factors until I got through with all them factors. But yeah, that's a nice little property. Just like factoring, you're always finding factors of these last numbers, okay? Now, before I do the factorization part right here, linear factors, let me show you. If you're lazy about doing all this synthetic division, let's go to the calculator and put this in the calculator. So I'm going to go to my y equals, and I'm going to punch that equation in. That was the x to the third minus 21x. And then we had a plus 20. Now, y'all, this method, you got to remember back in the past that the x-intercepts, those x values are equal to the zeros and solutions. So all we're looking for when we graph this is where's this thing crossing over that x-axis? And y'all watch this. When I hit graph, there you go. So look over here on the left. It goes -1, -2, -3, -4, -5. Well, that's one of our answers. We got -5. The one in the middle here is crossing over at 1. Well, that's one of our 3 zeros. And then let's see, 2, 3, and the last one crosses at 4. So all 3 of the zeros are graphed on this one. Now, what happens is sometimes if you graph it, it might only cross 1 time. And then you have to do the quadratic stuff because that means the other zeros are going to be imaginary if it don't cross all over 3 times. But y'all, the one y'all got should cross 3 times. And watch this. If you hit second graph to go to your table, let me go to that -5x. The y is 0. If I come down to the 1, the y value is 0. If I go down to the 4, the y value is 0. So that confirms that those 3 numbers are in fact zeros, okay? So, old school method was trial and error. New school, you're probably going to graph them and be done, but either way, okay? Now, the second part, the factorization of f of x into linear factors is, and then I'll have a big blank here. Well, y'all, all we're going to do is take each one of these zeros and put it in factored form. But remember, from the very first problem I did, when I took the zeros and I set them up as factors, I'm basically just changed the signs. So if you got a 0, a +1, your factor is going to be a -1. If your 0 is a -5, this factor will be x plus 5. And then for the +4, you'll get an x minus 4. Okay, so that was like when we set up x equals 1, x equals -5, x equals 4. When you went back and put them in as factors, we had to get a 0 on that right side, remember? So we either subtracted or added. So that's all they're wanting here is those linear factors, they called it, okay? So MATLAB is looking for this right here. So factors, and we just want y'all to realize that these factors are always opposite in sign, then they're zeros. All righty, y'all, guess what? That was 8.4. So notice y'all got a little bit of fooling y'all are going to be doing, okay?
A little bit. Don't insult us like that. You mean a lot.
Okay, a lot of fooling, okay? So let me stop my recording. That way I can